Okay. All right. Good. Okay. So it says 9% between 2018 and 2019, the population of that time increased. And then they now tell us what it was in 2019. So it's so interesting that questions on percentage can be tackled from any angle. If you notice, the one that we looked at yesterday came from the angle of they told you what the first value was, and then they now asked you what the final value would be after 2 years. I don't know if you remember that question. One question like that was asked was telling you that, you know, something increased by 4%, another one increased by 1.5%, which one is bigger, something like that after 2 years. So this kind of question is similar to that one. The only difference is that now they told you what the final value would be. They're now asking you what the initial value was. In this case, the initial value is what was the population in 2018. Now, the way you would solve it is remarkably simple. Just remember what the formula should be. So I'm going to use the ink control to annotate on this and probably send it to you later. Okay, so I'm going to write down the formula now. So the formula will always start from what the final one should be. So I'm going to put for 2019, I'll just put, okay, maybe I should call it mean. Okay, let's just leave it as final. F. Okay, so F stands for what it will be in 2019. So maybe I should just put it here. F is for what it is in 2019. I thought of a better way to do it. So let me just do it that way. So 2019 is represented by the letter F, and 2018 is represented by the letter T. Let me just use T to make it easier. Okay. Or in fact, we don't need the letter for 2018. Okay, let's just state the formula, then we'll put in what needs to be put in. So the final will be equal to the old one, the initial one, that's the one for 2018, plus the percentage increase, which is what? 9%. And 9% is simply what? 0.09. Now, did you notice something? I'm not really keen on writing 9% as 9 over 100, because this exam will allow me to use a calculator, so I can, you know, take some bold risks using decimals. Okay, most people don't like decimals, and decimals don't really lend themselves out as friendly guides to be used. But I'm good to go with it because I know a calculator would help me eventually. So the percentage times what? The original thing. So this is the formula. If you just remember this, you are good to go. So the only thing is that now we don't know what T is, but we know what F is, right? They told us that the population in 2019 was 165,680. That means this was the population after the 9% increase. So remember again, why is it a plus sign? Because we had an increase. If it was a decrease, then it would have been a minus sign, okay? But this guy would have still been on the left-hand side, and this guy would have still been on the right-hand side. Please take note of that. So I'm moving on. So that means I know what my F is. My F is what? So you can just, let me just draw an arrow straight to it to save me time of having to type all this. That's what F is, okay? So I'm going to just put that number there. Maybe I should even use the text property to make me faster. Okay, so here we go. 165 680 equals, I didn't type my 8 back there. 80, okay. Okay, equals Sorry, let me click here so that I can see what I'm supposed to type. Okay, so equals, so now T, remember T is the one that we're looking for, so we don't know it. Okay, so that's why you see me writing T there. Plus 0.09 times T, okay? Now, I know you're wondering, how are we going to help ourselves when it comes to that T? It's very, very simple, surprisingly. You already have like terms there, okay? So what do you think will be on that right-hand side? I want to see if you can help me out. What should happen on that right-hand side?
Pardon?
Eleanor, are you there?
Yes.
Okay, what do you think should happen on the right-hand side? I have T, and then I have plus 0.09 T. What should happen on that right-hand side? I want you to think carefully. Imagine we had, instead of T plus 0.09 T, we had something like this, X plus 2X. What would X plus 2X be? We'll start from there. X plus
3.
2X is what? 3. Why did 3 what? It's not just
3.
3. Thank you very much. 3X. So what do you think will happen in this case? We have one T. Of course, there's a 1 in front of the T. So that's why I mistakenly even said 1. But it's T plus 0.09 T. What do you think will happen in this case?
Oh.
Now, yeah, I didn't hear you. What did you say?
Well, 1.90.
1.09, right? Was that what you meant to say?
Oh, yeah.
Yes, it's 1.09, not 1.19, because the 1 is a whole number. So the 1 would add up with the 0 that comes before the decimal point. So that's why you will have 1.09, okay? And then don't forget your T, all right? Now you're looking for T. What are you going to do to both sides? Can you tell me?
Oh, divide.
Divide both sides by what? Now you need to be very careful whenever it comes to division. What are you dividing both sides by?
109.
1.09. Okay, so here we go. 6. Let's type out what should be there. Okay, I think at this point I would need. Okay, let me write down what I need first, all the things I need. Okay, so T, and I'm dividing both sides by 1.09. Please don't forget, don't worry, I'm going to use this guy and draw a line in between these three. So that's it. Yeah. So that's what it's going to be. Okay. So you can use your calculator to help you. Okay. So 165,680 divided by 1.09. What would that give you? Hope you have your calculator already.
152,000.
Okay, here we go. 152. Let's use the text property to make it faster. 152. How many zeros did you say?
3.
Okay, there we go. All right, and that's it. And guess what? I can check my value for correctness. How do I do that? Ask myself a couple of questions. Now, I'm not saying you must do this for all questions, but sometimes it gives you confidence that you know what you're doing and you did it correctly. How do I know that this value is correct? Number one, 2018 should be less than 2019. And if you look at it very well, 2018 is the value we just got now, 152,000. Whereas 2019 is what? 165,680. And that looks like it's more than that of 2018. So that means you are most likely correct. Okay. So do you have any questions on this?
Oh, no.
Excellent. Okay, so we move on. All righty. So here we go. It says find the reciprocal. Reciprocal. Looks like we're now seeing more of this word reciprocal. Please take note. Another word for reciprocal is the word inverse. Okay. So don't forget that word. Inverse and reciprocal are the same. Okay. And I told you what reciprocal meant. I reminded you of it yesterday. Flip a fraction, okay? Make the denominator the numerator and make the numerator the denominator. So in this case, I have 0.08. Now, there are two ways you can do this. On your calculator, I'm sure you will see a button that has this 1 over x, right? If you look for that button, right, you can also do this with that button on your calculator. 1 over x is the same thing as saying flip something, okay? And in this case, that something was x, okay? So if we understand that every whole number is the same thing as that whole number over 1, then if I flip a number, for instance, 0.08, if I flip it, then that means 0.08, which was formerly 0.08 over 1, is now as good as what? 1 over what? 0, I said the wrong thing, said 0.8, not 0.08, please. Okay, so this would also give me the answer if you want to do it this way. But let's pretend you didn't have a calculator. I always like to explore this scenario. Let's say you don't have a calculator. What would you do? Then it's the same thing as what we did yesterday. You would first make 0.8 a what? A fraction by, again, taking the decimal point as if it were 1, and then putting zeros for all the numbers after the decimal point. Please take note, not before, but on the right-hand side of the decimal point. So that's, sorry about that, but I'm sure you know what I want to write. That's 8 over 10, and 8 over 10 is, in lowest terms, is, no, sorry, I've not flipped it yet. This is it as it is, but flipping it now, let me just do this so that you understand that I'm saying flip it, okay? So the numerator will become the denominator, and the denominator will become the numerator. So this is what I have. Now you can quickly say 2 in 8 is 4, and 2 in 10 is what? 5. They are left with 5 over 4, which is as good as, I think you remember, I think we did something like this. One whole number, 1 over 4. And one whole number, 1 over 4 is the same thing as what? 1.25. Please, for the working, because of time, I don't want to do this again. But for the working of this, because we did something exactly like this, just look at star annotated PDF I sent to you yesterday. I showed you the details of how we got 1.25. I told you that the one whole number is this same one whole number. Both of them are the same. Okay. But the 1 over 4 is where you get the 0.25 from. That's 0.25. So I just brought them together. Okay. So are we good with that? Can I move on?
Oh, yes.
Okay. Now, x, we're told in the next question, x is equal to 4,700, correct to 2 significant figures. Question, complete the error interval for x. So I know there's a method to this thing, but the whole idea is that x has to be in between 2 values. That means x of 4,700 has to be between two numbers. Okay. The first one, the one on the left-hand side will be less than it. The one on the right-hand side will be more than it. Since we're presuming it's two significant figures and error intervals are usually in decimal places. But this guy doesn't have any decimal points. So I think it's safe for us to say 4,700. Okay, so two decimal places. So I'm looking at this. 10 divided by 2 is equal to 5. I'm using 10 because they said it's 2. We've taken out 2 digits so that it can go to two significant figures. Please, you may need to help me with the mark scheme to confirm this. So I'm using 5 as my the number that I'm going to use to do the deduction and the increase. So so if I subtract 5 from this, that's going to be 695. And then if I add 5 to this, that's going to be 4,705. Okay, so help me confirm. Is this correct?
Oh, yes, correct.
Okay. So now the method, you can see the method I used. I got this value 10 from here because of these guys. Okay. Okay, so that's why I got that it will be 10 because these two zeros were, in order to get it to two significant figures, we took out the last 2 digits. That's the tenth, up to tenth, unit and tenth. Okay, and then I divided by 2 because I'll be dealing with 2 values. Okay, so that was where I got the 5 from. Now, I simply remember the number on this side should be less, and the one on this side should be more. Don't forget it. That's the method for this one. Okay, so to get the less side, you subtract whatever value you've chosen. To get the right side, you add whatever value you've chosen. Okay, so are you good with that?
Yes.
Okay, all right, moving on. I think that's the only question on that page. Okay, it says write down the intercept of the graph. The intercept of this graph is very, very simple. Now, before, okay, so let me just write down the answer. The answer is 4. Now, I know you're wondering, how did I get 4? The 4 is that guy that's there, okay? So, this is the whole idea. Every quadratic equation, every quadratic graph looks like this. I'm writing it down. Taking the pains to use the ink because there's a way the X looks when you are dealing with algebra that can be confusing if you want to just type it. I'm sure you understand what I'm saying. The X for algebra looks like it's curvy, whereas the X on your keyboard is straight. Okay, so does this look familiar to you, what I just wrote down now? Does it look familiar?
Yes.
All right. So this is how usually a quadratic graph looks. Okay. This is the general formula for a quadratic graph. This is similar to the one for linear. When I say similar, I mean I'm just saying that linear too has its own, and linear was the one that I told you about yesterday. Y equals mx plus c. Okay. Now for linear, I'll come back to quadratic. For linear, the m is the gradient that tells us whether the the graph will tilt towards the right-hand side or towards the left-hand side. Remember, it's a straight line graph. Okay, so if the gradient is negative, it will tilt towards the negative x-axis. And if the gradient is positive, it will tilt towards the positive y-axis. This one is negative. Sorry, did I say y-axis? X-axis, please. Please, forgive me. This one is x-axis, and this one is positive x-axis for when the coefficient of x is positive. Remember, the word coefficient just means the number that's multiplying x in front of it. Now, C, there was a reason why I brought this up. C is the intercept on y-axis. Please take note, intercept on y-axis, okay? And the reason why it's on y-axis, you can see, because y is on the left-hand side of the equal sign, okay? So it is the intercept on y-axis, okay? Now, let's leave linear equation and come to quadratic, which is the one we're dealing with. How do I know this is quadratic? Because for linear, the highest power of x is 1. That's the reason why you don't usually see 1 written there. But for quadratic, the highest power of x is 2. Please take note, there's a power of x here that is 1, but it's not the determinant for this quadratic equation. The determinant one is the one that has the highest power, and that is 2. So what are the things we can pick from here? Number one, the coefficient of x squared will tell us whether the graph will tilt this way. You know, quadratic graphs are usually curves, or the graph will tilt like this. That's what we were discussing yesterday. If it's positive, it will open up towards the positive y-axis. Take note. For quadratic, the coefficient of x squared will tell us whether the graph will open upwards or open downwards like an N. If it will open upwards like a V, it will be opening upwards towards the y-axis. Whereas if it opens downwards like an N, then it will be opening downwards towards the negative y-axis. And that means this A was a negative number. So if this question was just interested in whether the graph would turn upwards or downwards, can you tell me which one that would be? If the question said you should tell us whether the graph for this equation, without drawing it, you know, you can mathematically tell us correctly that the graph will tilt upwards or downwards. Which one would it be for this question?
Downwards. No, upwards.
It will be upwards. Thank you. And the reason is because the coefficient of x squared here is what? 1. And you can see there's no sign, there's no minus sign in front of it. So that means it's positive. So anytime you don't see a sign, just assume that it is what? A positive sign. Okay, so it's, yes, you're right. It's going to tilt upwards. That means it will look like a U, okay, or like a V, if you like. Now, to the last letter, which matches this guy closely for linear. For the last number that does not have any x in it is going to be what? The intercept on y-axis. So I'm going to do that here and call it the same thing we called it then. Intercept. I'm not going to write intercept in full. Intercept on y. Okay? Which is what this our question is testing our knowledge of. And it's asking us, write down the intercept of the graph, blah, 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 blah. And it ends with +4. Please take note, if this +4 were -4, this is what I would have written. I would have written -4 here as the intercept on y-axis. But guess what? It's +4. So I'm going to erase that minus sign now. Like that. Okay, so here we go. The next question says, write down the coordinates of the turning point of this graph. Now, I hope you understand that they're asking us this question. There are two ways to solve this question. The first way is the way we are doing it now, by using mathematical principles. The second way is by doing what? Actually drawing the graph. And guess what? That way is going to be more time intensive. It's going to take your time, I can assure you. Number one, you have to get a table of values. Number two, you need to now start plotting a graph. I want you to imagine for a minute what the implications are. Now, what we're doing now is simply using mathematical facts to get the answers. So when they say write down the coordinates of the turning point of this graph, the turning point for this graph, yes, can you guess what the turning point would be?
Sorry, are you sure there's not a graph on top of it? Because these questions, they'll usually come after a graph.
Oh my goodness. Okay. Okay. Oh, I did to see it. I was thinking it was on its own. Okay, no problem. That's fine. Okay, that's fine. Okay, that makes it a whole lot easier then. Okay, that's fine. All right. Okay, so let me see. It says write down the coordinates of the turning point. Okay, so let's come and look at it. So the turning point is here, where it turns. All right, so let's simply gauge. Okay, so we'll look for what this value is, and then we'll also look for what this value is. Okay, that makes it easier. Okay, so x-axis is usually the one we write first. So that's going to be 3 and minus 5, right?
Oh, yes.
3 for x minus 5 for y. Okay, that's good. Okay. It now says use the graph to find the estimate for the roots. X squared minus, minus 6x plus 4. Okay, so they said we should use the graph to find the estimate for the roots. Now, the roots are simply where the graph cuts the x-axis. That is here and here. Okay, so are you ready? Let's see if we can get the estimate. Now, between 0 and 1, I have 10 boxes. That means each box is 0.1. So let's count 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. That looks like it happened at 0.8. Do you agree with that?
Yes.
Okay, so let's go on to the second one. Don't worry, take note, 0.8, 0.8. The second one is 5.1.2. So that's 0.8 and 5.2. Okay. So how do we write it? So that we can write it like this. Just write 0.8 and 5.2. Okay, so that's the reason why it says we should find them as estimates. It's agreed to the fact that they won't be whole numbers. Okay, so are you good with that?
Yes, yes.
Okay, so I want you to notice something. I know that we were initially solving this question as if there was no graph, but I want you to see how accurate the mathematical principles we use are. You see, I told you that the intercept on y-axis is 4. And if you actually look at it, the y-axis intercepted, the graph intercepted the y-axis as 4. That's where it intercepted it. Okay, so it's all in place. Okay, so sorry about that. Thank God we didn't we didn't solve it as if there was no graph all through. Okay, so we're moving on. It says Ella in, oh, sorry, let me take the first one. The first one is a right angle triangle. Okay, so you're going to help me out with this. Work out the value of x. Now, what do you think? What's the mathematical principle that will help us to solve this question? It's an acronym. And you have
Trigonometry.
given you some clues. Yes, what did you say?
Trigonometry.
Yes, it's in trigonometry, yes. But there's something that will help us to know what to do at this point.
Right on the sides.
Okay. Yeah, okay, don't worry. Let me just remind you. It's so well. Okay. Do you remember this acronym? Do you remember it?
Oh, yes.
Okay. All right. So the question now is this. Your calculator can help us with that. No problem. There's no issue. So you have to take your calculator to scientific mode to be able to solve this question, and I'll tell you why. Because by the time we find out which one is the correct one to use, there are three: 1, 2, and 3, and only one of them can be correct at any given time and for any given question. Now, why did I get SOHCAHTOA out? Because they said we should find the value of X. And what is X? X is the guy that's right there. Okay. Okay. And X is one of the sides. Is it in terms of either opposite or adjacent? How do I know X can never be the hypotenuse? Did you hear my question?
Sure.
Hello, Noah.
Yes,
Did you
hello.
hear my question?
What's X?
Yes, I said, how do we know that X can never be the hypotenuse of this right angle triangle? How do we know that? Can you tell me?
Because it's the adjacent.
Because it's the longest side of this triangle. Sorry, not that. That this is the longest side. 14.5 is the longest side of this triangle. Okay? So, and the longest side is the only side that qualifies to be the hypotenuse. Okay? So 14.5 is the hypotenuse. So this guy is we already know what the hypotenuse is. And it's there. Now, the question is this: what is X in relation to this angle, 53? What is it? Is it the opposite or is it the adjacent? There was a way I tried to show you how to get to tell which one it is. Is X the opposite or is it the adjacent?
Oh, it's the adjacent.
Yes, it's the adjacent. Why? Because it's touching the angle. So you can see it's very, very clear. The side X is like in contact with the angle. Now, had it been X was up here, I mean, let's just imagine for a minute. It's not here, but I'm just putting it there. Let's just pretend it's there. Had it been X were here, then X would have been the opposite. Why? It's not in by any way in contact with the angle 53. So that's how I know it's the opposite. But of course, right now it's the adjacent. So let's play with it that way. So since X is the adjacent, right, and we have the hypotenuse, so we're going to look for a formula that has adjacent and hypotenuse, and that's Mr. Carr, the guy in the middle. Did you see that?
Yes.
So what am I going to write? I'm going to write cosine of cos 53. So just help me ensure that your calculator is in scientific mode because we're going to be using it now. The only other alternative for finding cos 53 is to use 4-figure tables, and I guess you guys don't use it. for this exam. Okay, so cos 53 is going to be equal to adjacent. The adjacent is x, and the hypotenuse is 14.5. Okay, so have you put your calculator in scientific mode, or it's already there?
Oh yeah, I've done it.
Okay, all right, good. Now, remember, we're looking for x. What will we do to both sides to find x? Can you guess?
Multiply
What will
14.
we do to both sides? Yes, multiply both sides by 14.5. So that's going to give me 14.5 times what? Cos 53. So are you ready with the value for cos 53 for me? Please
Yeah.
make sure that it is not in radians. You know, your calculator can sometimes be in radians and you wouldn't know. I remember back then when we used to use our calculators, we had three possible measures for angles, D and R and G, degrees, radians, and grad. Okay, so please make sure that it's in degrees. So what's the value for cos 53?
8.72.
Now that's an issue. I cannot confirm it. But usually cosines are less than 1. They're usually less than 1. So I'm expecting to hear 0 point something. So can you help me confirm that your calculator is in degrees and nothing else?
Send it.
Because if you're, yes, it's supposed to give you 0 point something.
I can get a mark scheme.
Okay. Or okay, so let me do this. Don't worry. Let me use Google. Let's use Google. Cosine of 53 plus 53. Okay, so Google says this is the correct value. Cos 53 is minus 0.9183. Actually, 0.9182, blah, 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 blah. So I'm taking it to 4 significant figures now. 4 decimal places rather. Minus 0.9183. Okay, so this is another thing. Your calculator can put you in trouble for free. As in, so please be careful. I just take note of what I just said now, that cosines and sines can never, ever be more than 1. It's not possible. They will either be negative 0 point something or positive 0 point something. They can never be more than 1. And that's simply the way they are designed. It's good to know some of those facts. So if your calculator is giving you a wrong value, you can quickly correct yourself. So can you look for a way to get that? Can you look for a way to confirm that your calculator gave you this answer? I just want you to be sure so that you, when you're in the exam hall, you would also know how to use your calculator properly for this. So let me read the value out again. Minus 0.918282.786. Can you confirm that?
My calculator still says 8.73.
It stops at 8.73. Oh, hold on a minute. 8.73. It still doesn't make sense. Okay, you know what? Let's just hope they'll give you guys these values. I don't know. I don't know how it's going to happen, but that value is totally different from what I have here. But anyway, let me just take what I have here. 0.9183. Let me go back. Sorry. 0 minus 0.9 minus 0.918 and 3. Excellent. Okay, so can you help me multiply this? 14. Okay, so hold on. Let me even check something. All angles. Okay. Yes, there's no need for that minus. All angles that are less than 90, they are all their what do you call it? All their trigonometric ratios are are usually positive. So please just help me multiply 14.5 by 0.9183. What do you have?
13.31.
19. Did you say 19 or 13?
13.
Okay, 13. Okay. 13.31. Okay, there you go. And it's in centimeters. Okay. All right. Okay. So are you good with this?
Yeah.
Okay. So please, the key to solving this question correctly is to remember this guy. This is your life jacket, okay? That will keep you afloat in the sea of econometry. Your life jacket. All right. So we move on. Ah, this guy looks familiar. It looks really familiar. Okay, so here we go. The diagram shows a plan of Jason's garden. I think this is exactly the question we solved. Very, very familiar. A, B, C, O, and D, E, F, O are rectangles. Do you want us to skip this?
Okay. Actually,
Should we skip it?
yeah, fine.
Okay, all right. Because it's simple. It's just to find the area of a quarter of the circle, find the area of that's this side, find the area of this rectangle, find the area of this triangle, and find the area of this square, and add everything together. That's all. Very easy. Then do the other calculations there. Okay. Here are the first 5 terms of an arithmetic sequence. You are lucky in this kind of question. You are even told head ahead of time that it's an arithmetic sequence in terms of n for the nth term of this sequence. Okay, so here we go again. I always tell you, try and if they didn't tell you that it's an arithmetic sequence, you have to establish it that it's an arithmetic sequence. How? Simple. Ask yourself, how are the numbers generated? Look at 7 and 13. Look at 13 and 19. Can you see any trend? To me, it looks like between 7 and 13. If I want to check, was it addition that was done? Let's assume it was addition. So that's 7 plus 6, 13, right? Let's ask ourselves, if I add that 6 to 13, will I get the next number? And surprisingly, yes, I get 19. 13 plus 6 again is 19. Just to be, satisfy my curiosity. Add 6 again to 19 and you get 25. So you've already established now that it's an arithmetic sequence. I'm doing this because I'm pretending they didn't tell us, okay? But now that they told us it's an arithmetic sequence, how do we go from here? Simple. Just remember this formula I'm about to write now. The nth term is equal to, and of course, by nth term, that's what I'm writing here, Tn is equal to A, that's the first term, plus n minus 1 times d, which is the common difference. Okay? Now, furthermore, we move on. The nth term, so now we're applying it to this particular question, is given by A is the first term, And that means that A is what? 7. Okay? So just put your 7 there. Please take note, if the number has a negative sign in front, you have to put that negative sign here too, notwithstanding. Plus, now let me say something before I proceed, because I just talked about negative now, because you might be thinking all the numbers should be positive. It's not all the time. Do you know that it's possible that the common difference can be a negative number? Let me give you an instance. What if 31 were to be the first term? That means 31 was here where 7 was, and 25 was here where 13 was, and 19 was here where it was. You know, we just switch positions. Do you know that this kind of sequence is still an arithmetic sequence? The only issue now is that the common difference is negative. How do I know? When you add -6 to 31, you will get 25. Yes, 31 plus -6. The plus would be like it doesn't exist in that state. So it will now become 31 minus 6, and that's 25. Okay, so that in that case, you have a negative common difference. But for now, we are good. Okay, so we have, let's continue. Now, your n is a general thing, so you don't need to replace it. -1. Okay, here we go. And D is what? C. Are we good with this?
Yes.
Okay, now the final line. Oh, okay, second to the last line is going to be what? 7 plus, sorry, my plus is now looking funny. Okay, wipe it off so I can write it correctly. 7 plus, now this 6 is multiplying this whole bracket. So that's going to be 6n. Please take note, the 6 doesn't have any business with the 7. Well, at least for now, it doesn't look like it has any business. 6 times -1 is -6. So now you can collect like terms. 7 minus 6 is what?
Pardon?
7 minus 6 is what?
1.
1. So your final answer is 6n plus. Okay, so are you good with this? Did you follow the process that I used to achieve that?
Yes.
Okay. Now, look at the next question very well. You will see that they've told us that the nth term of a different sequence is 8 minus 6n. The question is -58 a term of this sequence? You must show how you get your answer. Okay, so how do we verify if a number is in a particular sequence or not, if it is possible for that number to be there? It's simple. Just equate the number to that expression and see if you can get a whole number for n. Did you get what I just said?
Yes. Yes.
Okay. All right. So here we go. Let me use the text property so that I will be faster. -58 equated to what? 8, what we're testing. 8 minus 6n. Okay. So we want to verify that when we're looking for n will be a whole number. Okay. So first things first, we're going to collect like terms. That means 8 will go to the left-hand side. That's going to give me -58. And because 8 was positive on the right-hand side, By the time it gets to the left-hand side, it becomes negative. And don't forget that there's a negative in front of your 6n already. So it doesn't be that negative goodbye. It takes it, it owns it. Okay? Next line, minus 58 minus 8. What will that give us? Now,
50.
yes, no. Take a look at what you're dealing with. You
Oh,
have minus, minus, not minus times minus.
66.
Minus, minus. What did you say?
66.
Thank you. Minus 66. Please take note. When you are subtracting in a number from a negative number, it's like increasing in the negative direction. Always remember that. So minus 66 is equal to what? 6n. Okay. I'm sure you can already see what's going to happen next, right?
Yes.
Okay. So we're going to divide both sides by what now?
6.
6. Thank you. So I think this is where my my text box can take a break, and we continue with our rusty old pen. So I'll divide both sides by 6, and of course, you know that 6 is going to clear itself from the right-hand side, like that. And 6 is going to go into, oh my goodness, I just committed a crime. I forgot the minus. So sorry, I'm going to put it back now. Okay, I hope you can see the minus there. Try to put it back without changing anything. Okay, did you see that?
Oh, yes.
Okay, so minus 6 will cancel minus 6. It's gone, right? And then minus 6 will go into minus 66. How many times?
11.
Thank you very much. And since it is negative divided by negative, what will happen? The answer will turn out positive, isn't it?
Yes.
So our argument is that is this. We'll say yes, comma, minus 58 is a term in 8 minus 6n because n is a whole number. In fact, this is just a whole number, a natural number. But let's just use whole number. The whole number or natural. You know the group of numbers that we call natural numbers, right? We start counting from 1, 2, 3, 4 upwards. Okay. Okay, so please take note. If the answer to this n were minus something or 0 point something or something point something, there's no way, absolutely no way minus 58 is a term in that sequence. N must be a whole number, okay? And usually without any sign, or of course, positive, that's what I mean. So did you get that?
Oh, yes.
Okay, so I can move on now, right? Okay, so I think I'll leave this for you to handle. Okay, no, this is not the beginning of the question before we fall into that graph of graphs again. Okay, so this guy is talking about a scatter graph. I told you once that a scatter graph is simply, I don't know how to put it. So in this case, you know, you cannot, the points don't form a particular pattern, or they don't seem to form a particular pattern by first look. It looks like they're just random, anywhere they are, they're just random. But if you take a look at it, you might be able to, and usually that's what data analysts do. They look at how figures show on a graph and see if they can plot anything to establish a pattern. Okay, so it says that the scatter graph shows information about the amount of rainfall in millimeters and the number of hours of sunshine for each of 10 English towns on the same day. Okay, so what does it say? One of the points is an outlier. Now, what's an outlier? An outlier is usually let me see if I can give you some, examples you can relate to. Did you get what I explained as outlier? What outlier means? Did you hear my definition? Hello, Noah.
Yeah.
Are you there?
Yeah.
Hello.
Hello. Hello.
Hello, Noah. Can you hear me?
Yes, I can.
Okay, good. Okay. For a bit, I thought you had gone offline. Okay. Did you hear my explanation for outlier?
Oh no.
Did you say yes or no? I didn't hear that.
Yes, yes.
Okay, good. So an outlier, again, I said, is one that's an exception. It's so different from the others. So the question is, which one is it? So if you ask me, I would gladly tell you that this one is the outlier. This one seems to be the outlier. Do you know why I think that's the outlier?
Because it's not. Wait. Yeah, because it's not in
Now,
line
did you say it's not in line?
with the others.
Okay, when you say line, which line are you talking about? Because there's no line here per se.
You
So
see
there's
how
something imaginary. Say, come again. What did you say?
you see how this is the only one that's not in the same, not going the same way as the rest of them.
Okay, I like that. I like that. So this is one thing about scatter graphs, right? I told you data analysts have to use something to predict. So if you want to be able to predict using this guy, it can't just be random like that. We have to look for a way and put a graph somewhere. And it's usually a straight line graph when we look at how it's looking, right? Now, if it's going to be a straight line graph, the points must not be too far from whatever graph we choose. So if you look at this guy very well that I just drew, this sketch I just drew, that looks like the graph of best fit. Okay, that's what they usually call it, the graph of best fit. And all the points should not be too far from it. It shouldn't be too far from it, no matter how they are. Anyone that's too far is an outlier and can be safely ignored. Did you get that?
Yes.
Okay. So they said write down the coordinates for this point. And we usually do x before we do y. So that means x is what? 2 and y is 1. Are you good with that?
Yes.
2 and 1. Okay. The next question. Oh, okay. It says ignoring the outlier Describe the relationship between the amount of rainfall and the number of hours of sunshine. Well, I mean, I'm sure you can guess by now. I mean, with this line I just drew for you now, can you guess? What kind of relationship is it? Anytime you see straight lines, either like this or like this, their relationships are very, very easy to get. It's very, very simple.
Decreasing.
Let me explain using this one. Now, yes, I like what you're saying, but you have to be specific. You can't just say decreasing. Which one is decreasing? Which one is increasing?
That's increasing. The other one is
When you
decreasing.
have, which one is increasing and which one is decreasing?
The one going
Is it
downwards.
the y-axis, the y-axis or the x-axis? Which one is increasing?
The x-axis.
X-axis, okay. So x-axis is increasing, and if x-axis is increasing, y-axis will be doing what?
Decreasing.
Did you say increasing, I for increasing, or D for decreasing?
Decreasing.
Decreasing, okay, thank you very much. So it's decreasing. So what kind of relationship is that? That sounds like inverse proportionality, isn't it?
Yes.
Okay, so that's what you're going to fill in here. That the amount of rainfall decreases as the number of hours of sunshine increases. That is an inverse proportional relationship. Okay, it says on the same day, another English town, there was 7 hours of sunshine. It says using the scatter graph, estimate the amount of rainfall in the town, in this town on this day. So it's simple. Now that we have what do you call that thing? An approximate graph, right? Just come and look for 7 hours here. 7 is somewhere here. Trace it to the graph, then trace it to, try my best to trace it to the x-axis. So that's the amount of rainfall there. So how do we get that value? Simple. Gauge the scale. Gauge the scale. There's no big deal. The scale here is 1 cm, 5 boxes to 1 cm. 5 boxes to 1 cm. So that should tell me, and you know, usually each unit, yeah, the 1 millimeter, each unit, you should always plan for it in terms of 10. Okay, that means each of those small boxes is 0.2. Okay, so do you agree with what I said now?
Yes.
Okay, good. So if we're to get this point, that means in the middle here is already 3. So 3.2, 3.4, 3.6. So the answer should be what? 3.6 mm. 3.6. All right. Are you good with this? Hello, Noah. Are you good with this?
Yes.
Okay. This looks like a histogram thing. It says work out an estimate for the mean height of the teenager. I think we have done something like this. Do you remember?
Uh, you multiply the height by the frequency.
Which of the heights now? Because there are two for each instance. Which of them are you multiplying by frequency?
So you find the H, and then whatever the H is, you multiply by the frequency.
Okay, so the question now is this. What do you think that H should be?
For the first one, it's 155. Second one, 165. Third one, 175. And so on.
Okay. 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 Yeah, I think I'll go with that. I wanted to ask you, how did you get 155?
155 is greater than 150 and is equal to 160.
And it's less than 160. Okay. So I think that's what you meant to say. It's less than 160. Less than or equal to 160. So yes, 155. Okay, so cool. Another way you can get that 155 is how I would have done it is 150 plus 160. You get your answer and divide it by 2.
Pardon?
Okay. Did you get what I just said? I said another way you can get that 155 that you got is to say 150 plus 160 divided by 2.
Uh,
Yeah, that's another way you could get it. So moving on, can I leave it for you to do?
yes.
Okay. Don't forget, after you multiply, you must divide by the total frequency. Is that okay?
Yes, yes.
Okay, cool. So take time critical now so that have some time to work on other things. It says water flows through each of the pipes that fill a lake at the same rate. It takes 4 of the pipes 12 hours to fill the lake. Work out how many hours it takes 6 pipes to fill a quarter of the lake. Wow. What do you think about this question? Water flows through.
I understand it.
Okay, what did you say?
I don't understand it.
Okay, you don't understand it. Okay, let's look at it properly. It starts by telling you that water flows through pipes to fill a lake at the same rate. The question goes on to say that it takes 4 of those pipes 12 hours. 12 hours to fill. Okay, now filling the lake. Okay, don't forget, filling the lake means that is the whole lake. Now you notice that the second scenario, it says how many hours it will take 6 pipes. So number 1, 4 pipes can fill up the lake in 12 hours. 6 pipes will um, will 6 pipes fill it faster? Let me just ask you, what do you think?
Yes.
6 pipes will fill it faster. Now, the only thing is that now, in the meantime, we don't have any grounds on which to compare, because the first part of the question talked about it takes 4 of the pipes. And let me see. Yes, so if you look at it very well, the lake is 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 going to be quite huge, and it needs 12. It takes 12 hours to fill it up. So since the second question seems to be interested in a quarter of the lake, let's ask ourselves, how many hours will that first one fill a quarter of the lake? That we can now know and compare it the with the last one. So how do we establish that fact? Well, let's look at it very well. It says 4 of the pipes. It takes them 12 hours to fill the lake. So a lake, if you divide it into 4, then that means that it takes 12 hours to fill the whole thing. Then it will take 3 hours to fill a quarter of the lake. Am I right?
Yes.
So now that we have established that fact, let me write it down. Sorry. I wanted to move around a bit. 4 pipes. It takes 4 pipes, 12 hours. So for me to find out how many hours it will take a quarter of the lake, a quarter of the lake is going to break everything down by 1/4. So that's going to be 1 pipe will be required, and it's going to take 3 hours. That is, it's going to take 3 hours. Are you with me?
Yes.
Okay. 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 All right. Okay. That's fine. Okay. So I was just going to write it down. So I just found a quarter of everything. That means you need 1 pipe will fill a quarter. Okay, so are we good?
Yes.
All right. Okay, sorry for that short break. So I've established that 1 pipe is going to need 3 hours to fill a quarter, 1/4 of the lake. Okay. All right. So let me just put that there. Okay, so now let's look at the second scenario. It says how many hours will it take 6 pipes to fill a quarter of the lake? Now, if 1 pipe takes 3 hours, 6 pipes will take shorter time. Do you agree with that?
Yes.
Okay, so let me see if I can write it like this. There's a way I usually write it. 6 pipes. Okay. Okay. So 6 pipes going to be what? For remember 1/4 of the lake. Now we agree that 6 pipes should be what? Shorter. So this is how I usually do this question. Since it looks like one increases one quantity, the other quantity is expected to reduce. This is what I do. So 6 pipe will be required to fix X. Okay. So let me see. Yeah. Okay. So this how it's gonna happen. We're going to go 1/6. Uh-huh. 1/6. Now, how did I get the 1/6? These are the guys I'm dealing with. Okay, 1/6 equal to. Now, instead of me to say this over this, we have a. Oh no, hold on. Since as one increases, the other one reduces. Yes, it's going to reduce. Sorry, not increase. If they were both going to increase, I would have done what I was about to do now. Okay. X over. All right. Please confirm to me that you understand what I just did.
Yes, I understand that. It's yes, true. Yeah.
Okay. Again, this is an instance of inverse equations. Inverse in terms that as one is increasing, the other is what? Okay, it's reducing. And again, take note of the questions I asked. If somebody cleaned um, if somebody, okay, let me just use this example. Somebody is trying to fill up a quarter of the lake, right? Uses what do you call it? 6 pipes to fill up that quarter of the lake, and we want to we we want to find out. Sorry, I think I mixed up some. He uses 4 of the pipes to and it takes 4 of the pipes 12 hours to fill up the lake. Then the second question is asking in terms of 1/4 of the lake. Okay, so that's it. We'll first find out what it would have done for that um for that size, for that, yes, for that portion of the lake. If you can find out how many hours you can do for a quarter, then you can now by extension calculate what can do for yeah, for a different measure. So always remember to establish whether it's increasing in value or reducing. That's a sure bet. Okay, so to find out, what will I do? I do something called cross multiplication. That means I'll cross multiply. That means 3 multiply 1, that's what? And x will multiply 6. 6. Okay, so we're looking for x, so you're going to divide both sides by 6. Going to say okay, so that's 3/6 equals x. So what do you think x will be?
3.
Huh? You sure it's 3? 1.
Oh, 2 is 2 hours, sorry.
Okay, so there we go. All right, next question, please. Okay, so I'm going to leave this stem and leaf diagram. You seem to be an expert in it. Am I right?
Yes, yes.
Median number. Median is also the one that's in the middle. So I'll leave that for you. After arranging things, the one that's in the middle. Okay. So it says simplify 4c plus 7d plus 3c minus d. What are you going to do there? Okay. So yes, what are you going to do for that question? Number 14a.
Collect the like terms.
Thank you very much. Just collect the like terms. So that's 7d minus d, that's 6d. 4c plus 3c, that's 7c. 7c plus what?
Plus
Plus
60.
6d. Yes. Okay. Okay. Hold on. Sorry. 7c plus, what am I doing? 6d plus 7d minus d is 6d. Then 4 plus 3 is 7d. Okay, yeah. Okay, I will go do that.
Yeah.
Now look at that second one. 5 into bracket 2m minus 6. Did you notice that that is the same thing that happened in arithmetic sequence where you have that d outside? D is multiplying all the things inside. Did you get that?
Yes, yes.
So can we go ahead and do this? So 5 times 2 is what?
10. 10
10m. Yes, thank you very much. 10m. And then
minus
what's the next? Minus, yes, go ahead.
minus 30.
Minus 30, yes. You're very correct. Minus 30, okay. Equals to 40, right?
Yes.
Okay. So what are we going to do next?
Rearrange.
Or collect like terms, same thing. 10m. This guy is moving to the other side to become what?
40 plus
Minus 30. Yes, go ahead. Plus 30, right?
Yeah.
Okay.
40 plus 30, yeah.
40. Okay, hold on. Okay. And that's going to be 70, right?
Yes.
Okay, so you know what to do, right? What are we doing to get m?
Divide them by 10.
Thank you. Divide them by 10. Let me see. And it's going to be equal to 7. So did you see that?
Yes.
Okay, that next one says there are X sweets in a box. There are Y sweets in a packet. It says write down an expression in terms of X and Y for the total number of sweets in 3 boxes and 2 packets. Okay. Okay. Total number of sweets in 3 boxes and then 2 packets. So let us look at 3 boxes. X uh, X sweets box. Okay. So how would you tackle this last one? This last question. There are X sweets in a box, Y sweets in a packet. Write down an expression in terms of X and Y for the total number of sweets in 3 boxes and 2 packets. Total number of sweets. So if you have Y sweets in a packet, right? No, are you there?
Yes.
So if you have Y sweets in a packet, according to what they say here, then you can have that 2 times 2 times, that's the number of packets. 2 times family and then Y. Okay. Move it up a bit. All right. Okay. So since they said total, right?
Yes.
X is 3 boxes. That's 3X. Okay. This is my issue with X. It always looks like something else. Okay, no problem. I'll use this now. Right. Okay. So here we go. So that's the expression. 2Y plus
3X.
3X. Thank you. Okay, yeah. So can we move on?
Yes.
It says a shop has 2 different special offers on milk. Okay, this is the first offer, milk 2 pints, milk 4 pints. Okay. Okay. Which offer gives you better value for money? You must show how you're going to answer. Okay, so are you ready? This one's going to be number crunching. Pay for 2 bottles, get one free. Pay for 1 bottle, get 1 bottle half price. All right, let's quickly do it. If you pay for 2 bottles for the milk, 2 pints, 2 bottles, is it not 75 times 2?
Yes. Yes.
What am I doing? Sorry, my bad. It's going to be 75 times 2. Okay, plus that's the okay, something like this. Okay, So this is this thing. Now get one bottle free. Two bottles. Two bottles. Get one bottle free. Okay. So what do you think we'll do with this? I'm just saying, say which one will give you highest value? 75 times 2 will give me the pay for 2 bottles. One bottle free. Okay. One bottle free. And this is how many pints? This is 2 pints. One bottle free means one bottle will come with every purchase that you make of 2 bottles. Okay. So that's going to be 4 pints at the end of the day. One bottle free means 4 pints. Uh, 4 pints. Okay, I think this is it. Okay, so 4 pints because of the 2 plus 2. So let's see what the other one will give us. The other one will give us now, pay for one bottle, get one bottle, half the price. Okay, so if we're to do the same thing for this guy, one bottle is going to be 1.28 plus pay for one bottle to get one bottle, half the price. Half the price. So half of 1.28, that's 64 pence. $0.64. So let me see. Okay. Now this 1.28 is the price, so because it says buy one bottle, get one bottle, half the price. So this one says let me see. Okay. So this one will give me 4 pins already. This one should have a better value. Let me see. So one bottle is 4 pins for this big guy. Half the price is another 4 pins. Okay. That's how many altogether? 8 pins. Okay. So it says which offer gives better value for money? The one that gives us much value for money is the one that we can achieve more with less money. Do you agree with that?
Yes.
Okay, so if I do that, let's look at this. Can you help me crunch this? 1.28 plus 0.64. 1.28. That's okay. No, don't even just do 128 plus 64. Let's convert it to points altogether.
1.92.
1.92. Okay, which means I can say that's 192 pence. Okay, on this side, 75 times 2 will give me what? 150, isn't it?
Oh yeah.
150 pence. Okay, and 150 pence can get me how many this thing? 4 pins only. Okay. So this is what I want to do. Sorry, did I say 4? Okay, yes. Okay, yes. All together, yes, it's 4. 1 bottle free. Oh my goodness. Pay for 2 bottles. Oh. I'm sorry. Pay for 2 bottles. That means it's already 4 pins. It's already 4 pins. That's 2 bottles. 1 bottle free will mean how many altogether? That would be 6 altogether. 6 pins in total. Yes, that's it more like 6 pins in total. So sorry, my bad here. That's 6 pins. Okay, so this one will give us, it says 8 pins. 8 pins. Okay, so the question now is, which one gives us better value for money? Do you know how I can establish this? Please give me 150 divided by 6. 150 divided by 6. I want to find out what is the cost of 1 pin in each case. 150 divided by 6 is what?
25. 25.
Come again. 25. Okay. So that's 25 pennies per pin. Please do the same thing for the other guy. 192 divided by 8. 192 divided by 8. That's 24, right?
£22.75.
So 192 divided by 8.
Oh, yes, 24.
24. Okay. So which one will give you better value? Did you know that on a face value, that's just looking at it, you could confuse it. You may not be sure of the answer. This question could have been very, very tricky, honestly. This is probably one of the trickiest questions in the whole paper. Somebody would think, oh, it looks like I'm getting more value with the one on the right-hand side. The jar looks bigger, you know. I mean, the one on the left-hand side, the jar looks smaller. But can you see the reverse is the case? With the one on the left, I have more value because I can get, oh, hold on a minute. Hold on a minute. So now, let's look at this thing very well. Better value for money. So the question that we have to ask ourselves before we leave this question is this. Do we look at value for money in terms of from the perspective of the person who is selling it, or from the perspective of the person who is buying it? I think we should look at it from the perspective of the person who is buying it, right?
Yes.
What do you think? Okay. So if that's the case, then people who are buying things, they don't like it when they spend more. Okay. They don't like it when they spend more. So I think the guy on the right-hand side would win the day somehow. because it looks like his own is 24 pence per pint. That's a lower price per pint than the other guy who is 25 pence per pint. So yes, the guy on the right-hand side has more value. So I'll say this guy gives us better value. So I'll say better value is this guy. Times better value. Okay. Do you agree with that?
Yes.
Okay. All right, let's move on. You can do this one now. 5/8 of 132. Okay, let's just do it together because I think we have done it, but it's been a while we did stuff like this. I told you that off is the same thing with multiplication. And when you say a whole number, then you might as well divide it by 1. So let's go.
82.5.
Did you, sorry, did you get it? Okay, so it's not a whole number, right?
No.
Oh, okay, no problem. You know what? Since it's not give us a whole number, let's just multiply 5 by 132 and divide it by 8. 5 times 132 divided by 8. What did you get as your
82.5.
answer? 82.5. Okay, that's the final answer, right?
Yes.
Okay, so right. So I'm moving on. The next one says, which of the write the following fractions in order of size, starting with the smallest one. Now, so if you were to find the smallest one, which one do you think would be the smallest? Now, let's not even look at it on face value. So you know what we'll do? Let's work at getting all of them to be what? 64. Can we agree on that?
Yeah.
Okay. So to get this guy to be 64 at the bottom, I have to multiply it by 16. So 16 times 4 is what? 64. And whatever you do to the guy at the bottom, you must do it to the guy at the top. So that's 16. Did you get that?
Yes.
Now, same thing with this guy, 32 and 64. 32 times 2 will give you 64. So that's going to be 64 at the bottom, and you must multiply by, and that's 9 times 2, which is 18. Do you agree with that?
Yes.
Finally, how do you get 64 from 8? 8 times 8, isn't it? Do we agree?
Yes.
And you must do the same thing to the guy on top. 8 times 3, which is what? 24. So, can you see that it's easier now to know which one is the biggest and which one is the smallest?
Yes.
So let's arrange it, starting with the smallest. The smallest by all measure is 16. So I'm going to write 1/4 right here, comma. Next guy is 18. So I'm going to write 9/32. Next is 21. 21 already lent itself because you didn't need to change anything. 21/64. And finally, 3/8, right?
Yes.
So can we move on now?
Yes. Yes.
Okay, cool. What next? 214 people go on a school trip. The people on the trip are either adults or children. Said there are 14 adults on the trip, 35% of the children on the trip are wearing a hat. Huh. Okay, what's the question?
I've done this question before, so I understand
Oh,
it.
you've done it. Oh, okay, cool. Next, how about this one?
Yeah, everything from 11 I've done it
Oh,
before.
really?
Yeah,
Everything from 11 upwards.
yeah, because I'd already started the paper.
Oh, I see. Okay. Oh, nice. Okay. Okay. Oh, okay. That's nice. Okay, that's fine. All right, so we finished right on time then. 12:32, not bad. So let me quickly save this and say I'll save it with annotated. With and let me see. And say that the time starts. Right. Okay. Perfect. All right. Okay. So we're good, right?
Yes.
Um, so I think we'll meet later, later in the evening by 6.
Yes, yes.
Okay. By then, would you have the other one? That would be 2021, right?
Yeah, yeah.
Okay. All right then. So till then, enjoy your day.
Thank you, too.
All right.